Here we look at some more examples on vector addition. We also include the use of sine and cosine function to determine the resultant vector values. In this example we have two vectors force 1 and force 2 as shown here. The problem asks us to determine the resultant using the graphical method, the polygon and parallelogram method. To draw this we rescale first the values of the magnitude by setting it to 1 cm per 10 newtons. So force 1 becomes 5 cm and force 2 becomes 7.5 cm. We draw the first vector positioned at the origin of the Cartesian system. The angle is measured from the positive x-axis as shown here. We then draw the second vector with its tail connected to the head of the first vector. The angle 60 degrees is measured with respect to the horizontal as shown here. To determine the resultant vector graphically, we simply connect the tail of the first vector to the head of the last vector and we see here it is about 12.3 cm. The angle of the resultant vector is determined by using a protractor and it is about 48 degrees with respect to the positive x-axis. This method is called the polygon or tail-to-tip method. The next method is the parallelogram method. The method simply replicates parallel lines having the same length and orientation but drawn in opposite directions with each other. Here we see that the method forms a skewed shape of a square. To determine the resultant vector we simply draw a diagonal line and we see that it is the same as the previous method and it is about 12.3 cm. The angle is also measured and it is about 48 degrees with respect to the positive x-axis. Here we have the comparison of both graphical methods which gave the same values. So, converting the centimeter units to newtons we simply multiply it by 20 newtons per centimeter and we get that the magnitude is about 246 newtons and it is oriented 48 degrees with respect to the positive x-axis. Or you could also say 48 degrees north of east. Here we determine the magnitude and direction of the resultant using the sine and cosine laws. First we use the graphical result obtained earlier which is the polygon method since it forms a triangle. We then relabel the terms as shown on the figure on the right. We see that we have the values for A and B and we can also get the angle C here. Looking closer at the encircled region we see that the angle C is obtained by geometry. Here we see that it is simply the sum of the gamma angle plus 90 degrees and plus the alpha angle. This gives us a value of 150 degrees. Now we have sufficient known values and if we compare the cosine function we are able to determine the function solving for C as the appropriate equation. Substituting the known values we are able to obtain the value of C to be about 241.83 newtons. Reminder, do not forget to set your devices or calculator in degree mode. To determine the position or angle of vector C, we determine first the angle B which is the angle between the vector A and vector C using one of the functions for sine law which we rewrite to solve for the angle B. The B angle is solved to be about 18.067 degrees. To determine the angle of the vector C with respect to the positive x-axis we examine the encircle region. We see that the angle of vector C is simply the sum of the angle B and alpha which is about 48.067 degrees with respect to the positive x-axis. Now we have here the final answer of the resultant vector using sine and cosine laws. The resultant vector is about 241.83 newtons with an angle of 48.067 degrees with respect to the positive x-axis or north of east. Comparing the graphical methods and the sine and cosine laws, we can say that the mathematical method is more accurate. This is because the mathematical methods are not limited by the physical constraints of the ruler and protractor, which can add more error due to the device construction and user handling the device.